Alright, so let's take a look at this mastery check. This mastery check is supposed to check your understanding of doing measuring with a scientific instrument, looking at sig figs when you're measuring to first best guess, also being able to change between units such as millimeters to centimeters, so a little bit of dimensional analysis, and also your checkup on calculations, being able to show the formula, substitution with units into that formula, and then answer with units. So these questions are going to be similar to the ones that you're going to be actually attempting. So make sure you read the directions carefully and keep your wits about you as you're answering these questions. It says answer all questions below. Show all work for calculations. All sig fig rules apply. Measurements need to be expressed to first best guess, and also show all equivalent statements when converting between metric units. So the first question, estimating the field of view in the image and fill in the required information, corresponds to this image right over here. So this is the image that you would see looking through a microscope. Since we've just been doing microscope work, we're going to use measuring with a microscope for this part of the mastery check. And so the field of view is outlined here as a circle. And in the field of view you see a series of lines which are representing basically parts of a ruler that's underneath the microscope that you're looking through the field of view at. And so in this field of view we see a number of lines. We have measurements on the left and the right, and we need to figure out the size of the field of view. So it says estimate the field of view, and we want to do that to first best guess. So first off, let's look at the least count of the ruler. Least count of any measuring device is just the smallest space that's indicated on that ruler. So if we look, the smallest space would be any distance between any two lines along this ruler. So the first thing we need to do is look at how the ruler is divided. So we have 2 millimeters here and 3 millimeters here. So the difference between the 3 to the 2 is 1 millimeter. So this represents 1 full millimeter. And let's see how many lines there are that break that up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, which means 10 spaces. So 1 millimeter divided by 10 spaces is 0.1 millimeters. So the least count of the ruler then is 0.1 millimeters. Make sure you put your units on that number because it is a measured number. Then the FBG, we need to figure out the diameter to first best guess of this field of view. So by doing that, we know it's at least 1 millimeter. Now, the least count we need to fill out, we need to actually decide whether to divide it into 2, 5, or 10 spaces. So the first best guess then would become a fraction of that field, the least count of the ruler. So if we decide to divide this in half, then our uncertainty would be, by the formula, 0.1 divided by 2, which, if we take a look at that and divide that by 2, we would get 0.05 millimeters. So we could put in here 0.05 millimeters would be our uncertainty. And so what we'd have to do then is to measure using the least count of the ruler and also get one decimal better, or 1 order of magnitude better, based upon the uncertainty that we've chosen. Okay, what if we had decided to turn it into 5 spaces? So this least count, we divided into 5 spaces, would then be 0.1 divided by 5, which if we do that really quickly, divided by 5 would be 0.02. And both of those would be fine. So you could have 0.05 or 0.02. I don't think we'd be comfortable dividing that space into 10 equal spaces. And so I don't think that having uncertainty of 0.01 is really going to be able to be done in this case. Okay, so now that we know our uncertainty, our first best guess of that field of view has to be either a multiple of 0.05 or 0.02. So we know that from our least count we get at least 1 millimeter. And then we have to visualize how many spaces there are in this part of that diagram. So if we divide it in half, we could either say 1.05 or we could say 1.1, which would be the least count. So 1.05 I think is the better measurement. If we were using our uncertainty of 0.02 millimeters, then we could probably see 1, 2, 3, so it'd probably be 1.06 millimeters. Notice how this agrees with this uncertainty and this agrees with this uncertainty. Okay, so number 1 is done. Number 2, it says using your answer from question 1 above, what is the field of view diameter when the total magnification is 100x? Now, at the bottom down here we see two formulas. You need to pick which formula to use to answer this question. So I'm going to use this formula because it relates field of view with a magnification to another field of view and another magnification. Since that's what number 2 is asking about, let's plunk that formula in there. So there's my formula. Now what I need to do is substitute. So I need to put in my field of view 1, my magnification 1. We want to find field of view 2 at a different magnification. Okay? So FOV 1 is from above. So let's take that. We're going to use 1.05 for this one. So take my 1.05, take out my letter, and I'm going to multiply that by magnification, which total magnification here is 10x. Okay, and that equals field of view 2, which is what I want to find, times the magnification, which is now 100x. Okay, then I would do some algebra, and to get FOV2 by itself, divide by 100x, divide by 100x. So 100 or 1.05 millimeters times 10 divided by 100. If we do that once real quick, times 10 divided by 100. Gives us 0.105. So, and make sure we bring our millimeters over. So, does this make sense? Let's think about that for a moment. So this is 10x, this is 100x. What happens to field of view diameter as magnification goes up? It's inverse, we know, so it should decrease by the same magnitude. So if this is increasing by 10, this should decrease by 10, which is exactly what it did. Now let's take a look at our sig figs. We have 1, 2, 3 sig figs here, and we have 1, 2, 3 sig figs in our answer right here. So now we've done what we need to do. We've got our formula, we've got our substitution with our units, x meaning magnification, and those cancel out, and we're left with millimeters. So FOV2 equals 0.105 millimeters. So number 2 is pretty easy. Now, what we want to do for number 3 is using our answer from the previous question, we want to know the field of view diameter in nanometers. So we have to go back down to our handy dandy metric line down here. Notice milli is represented by the 10 to the negative third. Nano is represented by 10 to the negative ninth. Now to do this conversion, first of all we need to put in what we know. So we know that this field of view is 0.105 millimeters. We need to multiply it by a conversion factor. And that conversion factor is going to relate the units we're in to the units we want to get to. So taking millimeters and going to nanometers. We need to figure out an equivalence for milli to nano. So if we look at millimeters down here, millimeters is 10 to the negative third, nano is 10 to the negative ninth. The absolute difference between them is 1, 2, 3, 4, 5, 6. You can also take 9 and subtract 3, giving negative 6. Okay, so 6, there's a magnitude of 10 to the 6th difference. So what I would suggest you to do is to actually do a division bar. So you want millimeters to cancel out. So I would set it up so that you have your millimeters canceling out. It's more difficult to do it on a computer here. So I'm going to put my millimeters down here. I'm going to have my nanometers up top up here. And I'm going to represent a division bar by just underlining that. So now we need to know how many millimeters per nanometers there are. So one of the things you can do is, since there's 10 to the 6th difference, we can say 1 millimeter equals 10 to the 6th nanometers. Okay, clean this up just a little bit. And then when we calculate through, we'll find that multiplying this times 10 to the 6th is going to move the decimal place 6 places to the right. Okay, so there's 3. We just need to add 3 zeros. Millimeters cancel. Millimeters cancel below. We're left with nanometers. So 105,000 nanometers. Check our sig figs. 3 sig figs. 1, 2, 3 sig figs. So it looks like that answer is all set as well. Okay, so 3 down, 1 sort of set to go. So now all we need to do is identify the number of sig figs that are in the following numbers. So if you remember your sig fig rules, Zeros are the only numbers that you're really worried about. All counted numbers are significant. So if we look at the zeros in this number, the 1 is significant. Any zeros between two counted numbers are also significant. So the 1 is significant, this 0 is, that's 2, 3, 4, 5. So there'd be 5 significant figures in this number. This has zeros to the right of a counted number, but there's also a decimal point showing. So we have 1, 2, 3, 4, 5 significant figures as well. Over here, we've got zeros to the right of a decimal point and zeros to the right of a counted number with a decimal point showing. So we have 1, 2, 3, 4, 5, 6 significant figures for that number. This number, this 0, is to the right, so it actually is just a placeholder. There's no decimal point here telling us that it's not significant, and we have this as a placeholder that says that there are 0 ones, which basically puts this in the tens place and this in the hundreds place. So this only has 2 significant figures. This one is similar to the one up here, or actually this one right here, and we have 1, 2, 3, 4, 5, so 5 significant figures on there. Okay, so hopefully you'll do just fine in your mastery. Just like I said, you'll see similar questions to this, but they won't be exact. The numbers will be different, so you have to apply your understanding on how to do calculations, how to figure out significant figures, how to do dimensional analysis, and how to measure with a microscope. So best of luck. Ask questions if you have them. Review how to do calculations, review how to do dimensional analysis, and review how to measure with a microscope. All right, good luck.